Our topic is how to calculate the exposure time for X-ray radiation. To calculate the exposure time for X-ray radiation, we must know about the exposure. Exposure is the amount of radiation striking or passing through the film. Exposure is equal to the product of the radiation intensity at the film and the required exposure time. So the equation will be exposure is equal to radiation intensity into exposure time. In X-ray, radiation intensity is controlled by tube current. So equation will be exposure is equal to tube current into exposure time. So exposure time is equal to exposure over tube current. So unit of the exposure is milliampere minute. Exposure shall be calculated at different distances using below equation. M1 over M2 is equal to D1 square over D2 square. M1 is equal to exposure milliampere minute at D1. M2 is exposure milliampere minute at D2. And the D is the source or focal to film distance, which we call SFD or FFD. To calculate the exposure time, we need to know following. Exposure M1 at distance D1 using exposure equation, distance D1 using UG equation, exposure M2 at distance D2 from film exposure chart, distance D2 from film exposure chart, geometric unsharpness from ASME 5 article 2, required film density which should be between 1.8 to 4.0. Film type we must know, for example, codec CX or AGFA D7 or D4. Weld thickness T, tube current from X-ray machine data and tube voltage from X-ray machine data. The geometric unsharpness is UG is the variation of the sharpness of the dividing lines between two density fields. FFD is the source to film distance or focal to film distance. OFD is the object to film distance and FOD is the source or focal to object distance. The equation for the geometric unsharpness is UG is equal to focal size into OFD over FOD. Here is the object which we are going to make X-ray. The base metal thickness is 15 mm and the weld thickness is 18 mm, and we will take the T 18 mm. From reference code ASME 5 article 2, for the material thickness under 50 mm, the maximum allowed UG is 0.51. F is the source of focal size, OFD is object to film distance, FOD is the focal to object distance, SFD or FFD is the source to film distance or focal to film distance. So SFD, FFD is equal to FOD plus OFD. So FOD will be SFD or FFD minus OFD. To calculate the minimum FFD, we must know the interested thickness, as we knew that our interested thickness is 18 mm and UG from ASME 5 is equal to 0.51 mm maximum for T less than 50 mm. So let's suppose required UG or selected UG is equal to 0.25 mm and OFD is equal to the thickness of the weld is equal to 18 mm if the film is in direct contact with the object. So FOD will be FFD minus OFD or FFD minus T is equal to FFD minus 18 mm. The focal size is equal to 4 mm from the X-ray machine data This is also supposed value. We just suppose that our X-ray machine focal size is 4 mm. We put all this data in this equation. UG 0.25 mm, this one, F 4 mm, OFD 18 mm over FOD, which we manipulated into FFD minus 18 mm. If we manipulate this equation, we will get the minimum required FFD, which is 306 mm. From the exposure chart, what we will get, if we suppose or select the voltage 120 kilowatt and we know the thickness is 18 mm, and this chart is for the FFD, which we call the D2 914 mm, and we will get the density 2.2. The film, this will be the film density 2.2. So when we intersect the voltage with the thickness, we will get the exposure 150 milliampere minutes, which we call it M2. So we have to calculate the exposure time for this data. Let's suppose the tube current is equal to 10 milliampere and tube voltage 120 kilowatt volt. Thickness we knew 18 mm and UG 0.25 mm, which we selected, and from the UG value, for this value the minimum FFD is equal to 306 mm, and from the chart, and this chart is for the codex CX, so the type of the film which we are using is codex CX. Always remember that your D1 distance at which you are going to shoot, at which you are going to make a shot, the FFD should be greater than the calculated minimum FFD. So D1 we selected greater than this value is equal to 400 mm. For film density 2.2, from here D2 is equal to 914 mm, this one. So M2 is 150 milliampere minutes. Exposure at D1 we need to calculate, and exposure time at D1 we need to calculate. So we have all this data. We will put this data into this equation. So we will get M1 at D1 29 milliampere minutes. So we will divide this M1 data to the tube current, as we knew that the exposure time equation is equal to exposure over the tube current. When we put the data into this equation, we will have the exposure time at D1. So the exposure time at D1 is equal to 2 minutes 54 seconds. I hope this video help you to calculate the exposure time for the X-ray radiation. Thank you very much.